Okay, so here what we will do is, first of all, what is conditional branch and what is unconditional branch? We have two type of branch instruction. Branch is what? That your current execution will get branched to some other address, right? So what we can do is, what we are having here is that we can jump based on certain condition, or we can jump without any condition. We can branch to certain instruction without any condition, right? So we will start with unconditional one. Do you know what are the conditional ones? You have studied this, right? So you should know what are the conditional one. Conditions will be like what kind of condition we are discussing? Yes, it is whether the zero flag is one or not, or it is the result is having carry or not, right? Kind of things are there. So few more we are having in this. We are having little more flexibility here, so that we will see what are the conditional ones. So we'll start with unconditional one. Do you know that which one is unconditional one? Yes, it is JMP. The same instruction we are having here, JMP. Now JMP, and we have to specify what? With JMP, what we have to specify? What should be the next operand? Yes, it is address. Okay. Now here we are having some options with this address, right? So what we are having? We are having JMP and then address. That is true. Now this address, actually we will have a label here, right? Now that address you can specify directly or indirectly, right? So we have two options: direct jump and indirect jump. Okay. Now that address can be, what is the option that we are having? That can be in the segment. You are working in certain code segment, right? So you might jump in the same code segment, or you might to go for some other segment as well. You can jump to, because actually it is a logical partition. It is not a physical partition, right? So it is possible that you might go, if you might want to jump to other location as well. So you have jumped this is not applicable for that just unconditional one. It is applicable for every case, right? So every jump, whether it is conditional or unconditional, this is true. We will have instruction here, opcode here, and the address. That address you can specify directly or indirectly, and you might jump to this in the same segment and in different segment. Okay, suppose you are wherever your current instruction is, and you are jumping in the same segment, then that instruction is known as intra-segment jump. And if you are going for different segment, right? That means you are jumping from one segment. Currently, your instruction is one segment, and you want to go to instruction written in some other segment. Then it is known as inter-segment. This is intra-segment earlier when you are jumping in the same segment, and if you are jumping to different segment, it is known as inter-segment. It is also known as far jump. It is all because you are jumping too far, right? Here we are having two options, that in the intra-segment, we have two options. That is near jump and short jump. There are two options we are having, right? Okay, so what we are doing here, we whenever first tell me, in intra segment and inter segment, there are two options we are having, right? In which case just IP will be changed when you are jumping. IP is what? It will point to the instruction that is currently executing. It is getting executed, right? In which case only IP is changing, and in which case IP and CS both will get changed. In intra, what will happen? Intra, what will happen? Only IP will get changed. Yes, true. In intra, of course, because we are not changing the segment, so what will happen? Only IP will get changed. And while here, what will happen? IP and CS both get changed. Right? Okay. Now, fine. So when IP is changing, that means so your 16-bit offset is changing, right? Now that value can get changed by your displacement, right? It is that how far you have to go. Like you have to go 2 instruction up, 2 instruction down, 10 instruction up, 10 instruction down. Certain memory addresses we are going to specify that from the current instruction I want to jump for 10 instruction next. So I want to go actually 10 or 20. Suppose each instruction is of 2 bytes. That means I want to go 20 memory location up or down, right? Kind of thing that you want to specify. So your displacement can be specified by what you can say 16-bit. If your specified address is 16-bit, then it is near jump, and if it is 8-bit, then it is short jump. Okay, so what is the case? What we are having now. Okay, so what is the meaning? Like suppose I am specifying that how far, how many memory address, how many locations I want to go ahead. That value, the displacement can be specified by 8 bits, then it is a short jump. And if it is specified by that 16-bit, that so how many locations, if I am specifying 8-bit, then how many locations are possible to get access to from the current location? How many location I can get access to if I am specifying my address by 8-bit, displacement by 8-bit? That means from the current instruction, how far I can go to. Okay, suppose I am okay, let me show you that. This is my current instruction, right? This is my current displacement. Okay, so how far I can go to? This is one, this is next location, 2 location, second location. So this has the displacement 1, this has displacement 2. Why? Because from my current instruction it is 2 location far, actually every 2 memory location away. Currently my IP is pointing somewhere here, my IP is pointing somewhere here, right? Offset can be like my IP value can be 1, 2, 3, 4. Here my this value of this memory location will be 1, 2, 3, 5, but displacement will be what? Displacement will be 1. That is how far from my IP the next location is, right? So this is known as displacement. So I can specify my displacement by 8 bits. That means how many memory location I can specify to. This is 2, right? That means I can, how many by 8-bit, how many values I can specify? Yes, it will be 2 raised to 8. That is 256 location I can specify. Are you following that? 256 location in current, if you are considering current 0 is the current one, then you can go for 255 locations you can specify in that way, right? So this is the next location 3. So what is the case here? So this is 3, displacement 3. In that way, by 8-bit, how many locations I can specify? How many location I can specify? Up to 255. Why? Because 0 is indicating the displacement 0. That is my current location. Is it okay? But now here one more term comes, or one more issue comes. We can say, what is that? Forward and backward jump. Okay, what is forward jump? Can you understand from the name that what is forward jump? Okay, okay. Before we go to forward and backward, so yes, jump to higher address, true. That is jump to greater address, true. So currently, if I am somewhere here, then current and my label, if I am having my label that my next jump next, if I am writing jump next, right? If I am writing jump next, then next is specified to the higher address. That is after some instruction, my next label will come here. That means I'm from my current address, I'm jumping to the next like this. Because suppose I am having, if I'm having the value 1, 2, 3, 4, I'm jumping to say 1, 2, 3, 6. I'm jumping 5, 6, 7. I'm jumping to 1, 2, 3, 7. So this address is higher. So I'm jumping forward. I'm jumping forward, jumping to the higher address. So this is known as forward jump. Okay. Okay. What about backward jump? So that will be some, okay, somewhere here, somewhere here, somewhere here it is written jump next. So this jump is backward. Yes, jump to lower address with respect to current address. Absolutely correct. It is absolutely right. So I am jumping backward here. So forward, okay, that is okay. That how can I mention the displacement here? That from the current displacement will be positive, and I can specify 255 addresses now. But what about backward? How to differentiate this backward and forward in terms of these values? Right? If I'm specifying displacement by 8 bits, it will be totally 255 values possible, right? But if I'm taking all positive, if I'm taking unsigned number, then it will just specify the forward jump. Displacement, but displacement can be negative as well. From my current instruction, if it is 1, 2, 3, 4, I may need to go to 1, 2, 3, 0, or I may need to go to 1, 2, 3, 1. Right? So what is my requirement? My displacement, if I'm going for backward jump somewhere here, where my IP address should be, or the address location must be 1, 2, 3, 1. Okay, so what is the displacement here? Can anyone tell me what is the displacement here? Here the displacement was 1. What is the displacement here? It is actually -3. True. So should I use here 8-bit? I have to use 8-bit. I have 255 values possible only because of 8-bit displacement. Should I use those numbers unsigned or signed so that I can cover forward and backward both jumps? Yes, I should cover it as a sign. So that's why the displacement, whenever you are specifying as 8 bits, then possible values are 255, but jump locations possible are, or displacement possible are, what are those? That -128 to 127. These are the possible displacement. Yes, -128 to +127 displacements are possible. Okay, so then same way, can you tell me what about if displacement is 16-bit? Displacement is specified by 16-bit. And can you tell me what are the jump locations possible? What are the jump location possible? Will it be signed or unsigned here? Will it be signed or unsigned here? Yes, it is going to be -2 raised to 15 to +2 raised to, yes, it is going to be signed. The number, if you want to write that 32,768 to 32,000, yes, it will be 32,000. Yes, true, it is correct. 32,767. Okay, so if you are having displacement by, so this is not correct actually. Up to 255, it will not go. Right, it will go up to just 127 location. And so 256 locations are covered here. All the locations are covered here, right? All these locations are covered. So this is all about the jump case. So let us go through this quickly. What is that? You can have 8-bit displacement, 16-bit displacement, short and near. It can be when it is a direct one, that is, so that we have already discussed. In the case of direct, we are having these options. In the case of indirect, what will happen? So what are the types of jump? It can be direct or indirect. It can be intra-segment and inter-segment. It can be forward and backward. These are the options that we are having, right? but they are of course not individual categories. Like intra-segment can be direct and indirect both, right? If it is direct, then you can specify your 8-bit and 16-bit displays kind of thing. So of course they are overlapping categories. So this we have already discussed. Let us take the example here of the how the displacement is calculated. Already you have done that here. Let us do that somewhere here itself here for taking a proper example. Okay, so what is the example here? That to move, you are moving some value to Cx, then you are adding it, then you don't have any operation, just some location is occupied, and you have to jump back to this. This is what some dummy code or some dummy program we have. We just want to see that how this displacement is working out. Right now, first tell me, it is forward jump or backward jump? It is forward jump or backward jump? Yes, it is a backward jump, right? True. But now, when it is a backward jump, that means my displacement will be positive or negative. Yes, displacement is negative. For negative, we are going to use 2's complement, right? So what I have to write as my displacement here, though it is a label, right? But when it is coded, when it is, you know that we can code that move instruction to machine code, right? We have done so, right? So when it is this jump instruction is coded to machine code, at that time, that this jump will have code EB. EB is the code for jump, as we were having for move, be something, and all those things were there, right? So right now we are not interested in that part, right? JMP instruction has opcode EB. How that opcode will work, that the move instruction we have taken, it is different for different instruction. So that you can verify, right? So don't worry about this EB machine code. Okay. Now this next is a label. This label is a backward jump, and hence it should be negative. What should it indicate? From my current value of IP, how many what value I should subtract, or rather, if I am considering that value negative, that what value I should add, so that I can reach to this instruction which that label is mean to. Okay, I repeat, from my current value of IP, how many, what number I should add? That number will be negative because of for this is backward jump, right? What number I should add, right? So that I can jump to, my IP value will become the one which is pointed by this label. Okay. 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 So someone is saying 4, someone is saying 3. Okay, and we will go to that point. Of course, we will go to that point. Okay, so that value, fine. Okay, so now for negative value, which value I should add, right? That value, that's why I have to take 2's complement. I'm going to take 2's complement here. Okay, now first tell me what is the value of I. What should be the value of IP for this? What should be the value of IP for this? For this instruction, what will be value of IP so that I will reach to this instruction? Yes, it is 0003. And what is the current value of my IP? When I am here, this instruction is executed or not? First, let me know. Is this instruction executed? Okay, is this instruction fetched? Is this instruction fetched? It is fetched, then and only then we will come to none. It is the jump instruction. So when instruction is fetched, what happens to IP? When instruction is fetched, what will happen to IP? What is the IP value? Is it 7? Yes, it is incremented. Point to next. Where it is pointing currently then? What is the current value of IP? 8? No. What is fetch? JMP and next. That is EB and FA is fetch already. Shade. Are you following? JMP is stored, the code for, yes, it is 9. Yes, it is 9. Code for JMP is stored at 7, location 7. and that is EB, and FA is stored in next location because it is hexadecimal number, na? Right? So it is 8-bit location, if you will see. Are you following that? Shail, are you clear with? Yes, yes, okay. So it is pointing to 9. So current value is 9. I want to go to 3. So what should be the displacement? Current value is 9. Current value of IP is 9. It should be 6. What will be 2's complement of 6? What will be 2's complement of 6? Calculate what is 2's complement of 6. Dev, what it will be? 10 1011 1010. Okay, you are having multiple answers. Think of, it is not difficult. Think of 1010. Okay. Those who are not clear, I can explain. What is that? Here I am writing it here. So what it is? What is the value of 6? So first of all, I will write it as 8-bit, right? So 16-bit because that will be the thing that will be added. So I'm writing here 16-bit value. Why? Because I have to add it to my IP, which is a 16-bit value, so that I can get it easily. That's why I'm writing 16-bit representation of 6. Then I will find out 2's complement, right? So this is a this is um, so how many bits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, then 110. Is it? Are you clear with this? Is 16-bit representation of. This is 16-bit representation of 6, and then if I want to go for 2's complement, so it will be here. What I will do, if you remember that shortcut, I'm not going to do actual process. The shortcut was that from wherever that one occurs, you keep that one as it is, and other values you should alter. Other values you are going to alter. So can you tell me what will evolve? What it will be? And if you want to, okay, so what it will be? Yes, it is going to be 1010, right? So this will be as it is. This will be altered. This will be, I mean, this will be as it is. This will be also as it is, and this all are altered, right? So that is what we are having here. So then let us verify. So whether it whether it works or not. And suppose, okay, so this is and what I am specifying here, because I know that okay, so now let us add what is the current value of. So what is current value of our IP? This is current value of IP, that is 0009. That is the current value of IP, 0009, right? And then I'm adding that value that you have specified, that is this one. Okay, and then if you will add this two, definitely this is going to be 1, this is going to be 1, this is going to be 0, and this is 0. Of course carry is there, that's why all other values are 0. So if you will see, the value is nothing but 0003, right? 0003. So this is how we will obtain the value. Now actually what now tell me, how many bits of displacement is sufficient to represent 6 minus 6? How many bits of how many bits are sufficient to represent displacement of 6, 8 or 16? 8 bits are sufficient, right? Suppose I am taking this 8 bits out of the 16-bit representation, what it will be? Can you tell me what it is? What will be the hexadecimal number for this? Yes, it is FA. Yes, it is FA, and that is what is specified here, FA. That is what is specified here. Now what exactly happens, right? So now what will happen, that your assembler will come to know, okay, next instruction is somewhere here. The next instruction is somewhere here. So that how many bits are sufficient for this instruction? How many bits are sufficient? So you will say okay, 8 bits are sufficient, and that's why it will consider the offset as FA. When the process will take place at that time, what it will do? It will convert this word. I mean this byte to, or rather I should say this byte to word. How to convert this byte to word? Whatever your sign bit is, it is extended to word. If you remember, that was the instruction that we had. That instruction is internally executed, and you are going to get this as a displacement. This is a whole word, right? So what assembler does, I repeat, what assembler does, assembler comes to this, it comes to, okay, it is a branch instruction, label is next, this next is already encountered, it will calculate the displacement is -6, okay, 28 bits are sufficient, that means just one displacement is sufficient, right? And that's why what will happen, just 8-bit displacement is sufficient, and hence what it will do, it will use just specify 8 bits for that. And whenever the calculation will take place at that time, because I have to calculate with 16 bit, because I have to add or subtract from the 16 bit, that word is extended to and that byte is extended to word. How it is extended, that method already, that instruction that is internally executed. Okay, so these are the steps. Now, how many bytes are needed for jump instruction of when the displacement is 8-bit? The displacement is specified by 8-bit. How many bytes are needed by this jump instruction? 2 bytes are sufficient. That you can see that EB and FA. And it is 16-bit, then the displacement, this FA will be specified by 16-bit. That is what the meaning is. I mean, it will not be just 6 location far. It will be sufficiently large distance. So you will need a larger number here. So you will need 16-bit displacement here. The label will be somewhere far. It will be beyond 128 locations. So 3, yes, how many locations, how many bytes are needed? There will be 3 bytes, right? Yes, it will be 3 bytes. So jump may take 2 bytes or it may take 3 bytes based on that which kind of instruction that you have specified, which kind of jump location that you have specified. Okay. Now, fine. Now what here it was possible to decide that you have to jump to next because you have to jump backward. You have to jump backward because next was already encountered. So you know that okay, my next instruction is already fetched, and I know where it is located, and I know what was how many locations far I have to go because it was a backward jump. So if it is a backward jump, and if the displacement of is 8-bit, I will need 2 bytes. If it is a backward jump, and if the displacement of 16-bit, I will need 3 bytes. No doubt in that. Okay. What about forward jump? Where next level is not yet encountered. Your assembler does not know where next is located, where it is a forward jump. Will it be able to judge whether the 2-byte instruction it will be or it will be 3-byte instruction? It will not know where next is there. It will complete the entire portion, and then and only then at that time it will assembly is not yet, it is just coding part, it is yet to be given to microprocessor, right? Assembler is the thing that will first it will assemble the code, and then it is given to microprocessor for the execution, kind of thing that you can understand, right? So while assembling, how many bytes it is going to reserve? How many bytes it will go, how in memory, how it will reserve? Yes, it is going to reserve at 3 bytes. Why? Because possibly your next is located 16-bit apart. It is possible that EB will indicate, okay, it is intra segment jump. It will show that EB will indicate it is intra segment, it is not inter segment, right? So it is intra segment. It is sure that it will be in my segment, but I'm not sure that it will be 16-bit or it will be 8-bit far. I mean, displacement can be specified by 8-bit or 16-bit. So it is going to store it as 3 byte. What if, suppose I have stored 3 byte, and if the next instruction is encountered at displacement which is specified by 16 bit, no issues in that. What if the displacement comes nearer? What will happen to 1 byte is used, right? Out of this 3 byte, 2 bytes are used because one will be opcode, one will be displacement byte 8 bit. What about one extra byte that is remaining? It will be filled by no operation. If it is so that if you are reserving that if you are reserving that 3 bytes and you need only 2 bytes because of 8 bit displacement, what will happen? That one extra byte in the memory is filled by no operation instruction. By whom? By assembler. So, but someone will say, okay, it is just totally waste of one memory location, right? But what we can do, you are not informing your assembler that what kind of jump it will be. So, so what you can do, you can use this assembler directive. This is assembler directive. What is that? You are informing your assembler that this will be of short kind of jump. It will not be a near kind of jump. Though it is a forward jump, but it will be a short kind of jump. So there is a short assembler directive, right, which will instruct assembler to reserve how many bytes? Short assembler directive will instruct assembler to reserve how many bytes for jump instruction? How many bytes? 2 bytes for yes, 2 bytes for instruction. Or displacement you are talking about, then it is displacement of 1 byte or 8 bit. I think cable I think you were thinking in that way. I Okay, fine. So displacement will be of 1 byte, but I am asking that how many bytes for instruction, so that will be 2 bytes for instruction. So that so that will save your one location. Okay, so this we have already discussed. So this is what we were talking about, that opcode, then low displacement and high displacement. Like if it is just 8-bit displacement required, that this only 2 bytes are needed, and if it is 16-bit displacement, then you will need all 3, right? And when we are going for indirect jump, right? So when indirect part comes, at the time that instruction that instruction types are coming, that is the different instruction formats are coming, right? So at that time, what will happen, like your mode can be that directly from SI. If you remember all those things, we are not going to study for this because we are not much interested here. But if you remember, the different instruction formats will come whenever it is coming in this indirect part, right? That you can specify your address in what you can say, in register itself, or you can specify using that index addressing mode or base index addressing mode, right? Register indirect addressing mode. So different addressing mode comes. So in that way, mode and RNM, if you remember those two combinations, these three are fixed. That mode and RNM combination will indicate that which kind of addressing mode you want to use, 00. Then what will be the value of RNM, that will decide that from where you will take the address. Sometimes it is needed that you need to add BP, SI and displacement as well. So it is possible that you might need this displacement as well. Otherwise logic is same, just when the indirect part comes, this extra part comes, which will specify whether it is index addressing mode, whether it is register indexing mode, register indirect mode. Different index addressing modes are specified using this one, right? This we have already discussed, right? And right now we are not interested in focusing here, because right now we are not going to discuss. I mean, we are more interested in the functionality and usage of this jump instruction rather than the machine codes. But yes, but you should understand, you will be able to understand if you will go through the table given for this. Okay. So it is not difficult, but already we have covered. That's why we are the same type of discussion for this jump instruction. We will not discuss. Okay. So fine. So this is all about this we have already discussed, right? If you are If you have a 16-bit displacement, then you can cover this, otherwise this. Okay. And when you are covering this much, this many location, that means you are covering entire segment, right? Okay. Now question is, what if suppose I am somewhere here, right? This we have discussed, right? Suppose I am somewhere. This is my core segment, right? This is my code segment which start, and this is my offset 000. That means my code segment starts from here. From here it starts, right? And I am writing my some instructions are written somewhere here. Okay, this is my third location. At third location or at fourth location, okay, if I am specifying displacement of -6, at fourth location, I'm specifying displacement of -6. That is a backward jump where the displacement should be specified by -6. Then backward 6 location you have to go. But in that segment, but this can be intentional or unintentional. Maybe by some reason that happens. Then what will happen? Are you getting? You have to go backward, right? It specifies that it is intra segment. So what will get updated? Will it update CS? If it is intra segment, of course specifies this is intra segment. Will it will it change your CS? No, right? So CS is not changed. What will happen if what will happen if IP is changed, right? IP is changed to what? So what will happen actually? It should go to 6 location back, right? So it will get rolled over, right? So 1 location, 2 location, 3 location, 4, 5, 6 location will be from the end of the segment. The remaining locations are taken, that is rolled over. You are considering from here, this is the last location. Whatever the last location is of your defined segment, from that 3 locations are taken, second and third. Somewhere here it will jump. So you will, because you cannot change CS, right? So if you want to go 6 location back, you can go only 3 location back. So other 3 locations are taken from the bottom of the segment. So you can consider it is rolled over to the end of this segment. Is it okay? And same way, if it is somewhere here at the end of the segment, if you are writing forward jump to 3 locations, so it will start from the beginning of this segment. Okay, so this is what happens if the jump happens where it has to go to beyond the segment level, it will get rolled over. Is it making sense to you? Are you clear up to this, so that I can go to the next part? Up to this, are you clear with? Inter-segment I have not taken, Priyank. I have not taken inter-segment yet. We have just discussed intra-segment. And what we have done here is that suppose it is in this inter-segment is what, intra-segment is what, that in the segment I have to jump. And if I am at the current location where the displacement is, where my displacement is like it is going beyond, right? Like if I'm at the 4th location from the beginning of my segment, right? And I'm asking that go backward 6 locations. So 2 locations will be taken, or whatever the locations are remaining, that will be taken from the bottom of this same segment. Segment will not change because it is the instruction of the intra segment. That is the only thing. We have not taken inter segment yet. Everyone is clear now? What about others? Are you clear with it? Inter-segment is yet to discuss, right? Okay. Now, what will be intra-segment? Let me write that intra-segment or inter-segment. Right? For inter-segment, we will have, suppose in my data, suppose this is my data segment. What I have written in my data segment, of course, whatever is the initial ones and other things are that, but somewhere in my data segment it is written as some variable, ADDR is my some variable, and it is of double word type, and its value is 0 FFFF, and this is 0000000H. So this is some variable which is of double word type, and the double word value is FFFF000H. Okay. Then somewhere in my code segment, it is written as move. Of course, some other initial and later part is there, but I have written like move SI, comma, offset ADDR. What this will do? What this instruction will do? What this instruction will do? Move SI, offset ADDR. What it will do? What is the meaning of this? What SI is point? What is the point? What SI is pointing to? Yes, it is pointing to offset address of ADDR, right? It is pointing to offset address of ADDR, and then I'm writing is that jump here. I'm writing this instruction. What is the meaning of this? What is the meaning of this double word point D word PTR? What is the meaning of D word PTR? If I write byte PTR, what is the meaning of that? If I write here byte PTR, what is the meaning of that? Yes, byte point. If I'm writing byte PTR, what is the meaning of that? Byte pointed by location SI. Whatever is stored in SI, that should be taken as address, and byte pointed by that location. That is byte PTR, right? Here, what I am specifying here, I am specifying that double word pointed by location SI. That means SI is pointed to ADDR. So whatever is stored in SI, at that location, whichever double word is stored, that means you have to access all these locations. All 4 locations of memory is accessed, and you have to jump there. So actually, which value is, so what we are specifying? We are specifying here all this double word, that is we are specifying all 32 bits here, jump 32 bit kind of thing we are specifying here. What is the instruction format of whenever it is inter segment? What is the specified format? I let me show you that if it is inter segment, the format is that opcode, then offset low, then offset high, then segment low and segment high. This is what the format that we have. So here, if you want to see that first 8 bits after opcode, whichever will come, first 8 bits will be that will be low, offset low, right? Then whatever 8 bits will come, that will be the higher bits of offset. 8 bits next will indicate higher bits of offset. Then whatever will come, that will be pointed by segment low, and that whatever is pointed by is segment high. Currently, what we did, we wrote like JMP D word PTR SI. Now this can be replaced as at SI. How these values are stored? At location SI, how these values are stored? SI is actually it is pointing to ADDR. It is offset of ADDR. And now, can you tell me if I am storing this value FFFF0000H, how it is pointing to? How it is how it is stored in memory. So lowest first, lowest to highest it is stored. So can you tell me at ADDR location, whatever the offset is, FF is stored or 00 is stored? Whatever offset value that ADDR is having, yes, it is stored 00. Yes, value is stored is 00. So actually what I have written here is 00. What will be the next value at the next byte? Will it be 00 or FF? Two values only, right? Because it is hexadecimal, so only 8 bits are stored. Only 8 bits of next will be also 00. What next will be there? What will be the next value? FF. And what will be the next value? Again FF. So this is how it's stored, and that is what I am pointing here. So I am actually pointing that actually this is indirectly meaning that this indirectly means that JMP to what 0000 FF and FF. So can you tell me where it is going to jump? I mean, this should be in small bracket, right? Rather, it should not be in bracket at all. This is what I'm meaning here. JMP opcode, whatever the opcode will be, whatever JMP's opcode will be, that JMP opcode, and this is what I'm specifying here. So can you tell me what will be the segment address now and what will be the offset address where this will get jumped to? This jump instruction will jump to which segment and which offset? This is jump opcode. Yes, segment will be, so offset low will be what? This is offset low. This is offset high. So offset high 8 bits are 00, offset low 8 bits are 00. That means offset is 0000, right? Segment low is FF, segment high is another FF, right? That means segment total 16 bits are FF, FF. So where we are jumping here to? We will jump here to the location FFFF0000. That is where we will get jump. Everyone is clear with this? Everyone is clear with this? Any doubt? Should I repeat with another example? Do you need another example for this? Okay. 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 Let me tell you, suppose it is like, okay, and let me write it like, okay, now how this ADDR is stored in memory? Tell me how this ADDR is stored in memory. Suppose ADDR, let us take some offset of ADDR is, ADDR offset value is, say, ADDR is stored. Where ADDR is stored? ADDR is stored at location, whatever CS, currently my CS, I am taking my current value of CS, or rather it is stored in DS, no? So DS, okay, ADDR is stored at some location, say 0400, this is segment address of data, this is data segment, and its offset address of ADDR is 1234, or rather I should not write 1234, 4567. So this is where ADDR is stored, right? What will be the first location that is storing of ADDR? What will be the first location of ADDR is storing? Yes, it will be. Yes, it will be AB. Then, sorry, it is AB. Then next location. What will be that location? 6. I am not writing whole, but it will be 6. What will be that 6? And 4, 5, 6, 8. Yes, it is 4, 5, 6, 8. And what value it will store? It is storing FF. Then 6, 9. It is storing. What is this? 3, 4. And what is stored? 6A. 6A stores what? 1, 2. Exactly, right. 2. Now, when this code executes, then can you tell me uh, what will be the value of SI? What is the value of SI? What will be the value of SI? 4567. Correct. It is why? Because it is offset address of offset value of address. Offset value of address is 4567. So SI value is 4567. Now what you have to write? You are writing here that what you are writing here is that your jump instruction, just a second. Okay, so you are writing jump where to jump. So you are writing like jump double word pointed by SI. What is the double word? That is how many location you are going to access from location SI. Location pointed by SI is this, right? So because value is 4567, so it is location pointed by is 4567 here, right? And double word, that how many locations you are going to access from this location pointed by SI? 2, 1 or 4 locations? 4 locations. Why? Because it is double word pointed. So 4 locations that you are going to specify. What are those? Those are AB, values are for those are AB, FF, P4, 1, 2. Now, this is what a jump, whenever I'm writing jump, that means I'm indicating that jump means whatever opcode of jump, whatever it will be, you know that how to calculate that opcode of jump now, right? So that whatever the opcode of jump will be, that will be just 8-bit, right? That will be 8-bit if it is directly specified like this. I mean, if it is it is not indicating whatever the it is, can be 2-bit or 2 byte or 1 byte, that depends that what kind of addressing mode you are using. If it is direct, then it will be different. If it is indirect, then it will be different, right? So that is okay, but whatever the opcode of jump it is specified like this. Now we have to compare it with this. What is the whenever it is intersegment, then how it is working? First of all, it will, whatever will be encountered, that it will see that it is opcode, right? So yes, of course, this is opcode of jump. From that, it will come to know that I have to go for direct jump here, right? And then here, because we are pointing to direct memory of locations are given, that's why it is a direct jump, right? So it will come to know, okay, it is a direct jump, right? Then what it will encounter, whatever will be encountered is low value of offset. What is the next thing encountered here? Next thing encountered is AB. So now wherever you want to jump, it's in offset. If you will see in offset, right, there will be, if this is your offset, there will be 2 bytes of offset, lower byte and higher byte. Lower bytes are AB. That is what is indicated by this memory, this code that is encountered. Okay. Then next whatever is encountered is high offset high, right? So that will be whatever is encountered, that is offset high. So this is what offset high will be. So now what is your offset value? What will be your offset value? Offset low was AB, offset high was FF, that is high 8 bits are FF. So now what is your offset value together, if you will see? Yes, it is FFAB, true. It is FFAB. Same way, next two encounters will be that segment low and segment high, right? Segment low and segment high. So can you tell me what will be segment address now? What is segment address where you have to jump? Segment low and segment high. What is the segment address that you have to jump? Yes, it is 1, 2, 3, 4. Yes, it is 1, 2, 3, 4. Right. So where at which location actually you are jumping to? You are jumping to the location wherever you are currently. whatever your code currently has, whatever your CS value is there, after this instruction, your CS value must have 1, 2, 3, 4 value, and your IP value must be what it should be. It should be FFAB. Are you following that? Now, anyone is having doubt? Should I take one more example, or are you clear with this? Everything is clear here, or should I repeat with the example? Is it clear, yes or no? Okay, that's great. Okay, and if it is indirect one, right? If it is indirect one, it is the same as this one. The same as this one, indirect one, because in indirect you have to specify the mode and RM. Just this number will get altered to. It is same as this. Just what will happen for this indirect jump? Indirect inter-segment jump. When it is indirect, that means addressing mode comes into picture, right? Then this value becomes just, otherwise it is same. Just this value changes to 101. This value changes to 101. Otherwise, this together, this and this will indicate different addressing mode, and if it is displacement is required, like BP plus SI plus displacement, and that displacement is specified by this. Okay, so concept wise it is same. So we have completed in unconditional jump, the inter-segment, intra-segment, and if it is intra-segment, near and far, near, short and far. So any doubt in this jump instructions? Okay, so we are concluding our lecture here. More details on jump and programs on jump will be taken in the next lecture.